Okay, good evening. We want to quickly look at a transformer. So in previous classes, we've talked about an alternating current generator and a direct current generator. Okay, so an AC and DC generator, and we'll see how an AC generator can be converted to a DC generator by replacing the slip rings with split rings and the commutator as well. Okay, so an alternating current is simply a current that changes periodically with time. Okay, changes it's sinusoids. Yeah, it changes. Why? A direct current is a current that flows in one direction, even though the magnitude of the value of the current may change or may vary, but the current itself flows in one direction. Okay, now what is a transformer? Quickly, a transformer is an electrical device for changing the size of an AC voltage. So what comes to our mind? The first thing that comes to our mind is this: in a transformer, what flows, the current that flows into a transformer, it's an alternating current. So the current that flows from our network stations, from our electrical power stations, from our high tension electrical networks to our transformers, they are alternating current. So that fact has been established. So therefore, it changes the size, the magnitude of an alternating current voltage. Now it acts to increase or decrease the EMF, the electromotive force of an alternating current. Quickly, let's see the structure of a transformer. A transformer is made up of two sets of coil. In simpler terms, the primary coil and the secondary coil. Another name for the primary coil is the mains coil. We call it the mains coil, M-A-I-N-S, or we call it the main coil, M-A-I-N, of the input coil. The input coil, it is the coil that takes charge, that receives that. In short, it is the coil that takes the main voltage from the electrical power stations. I think about 220 volts to 240 volts or thereabout. So that's the primary coil. And the secondary coil, the primary and the secondary coil. The secondary coil is called the output coil because that is one that gives voltage to the houses nearby. The primary receives the main voltage, while the secondary coil distributes the main voltage. So the primary coil and the secondary coil. The primary coil is the input winding of tons of wire, and the secondary coil is the output. I've said that before. The output winding. Now, the coils are wound round a soft iron core. Why? Why are they wound? Wound means to wrap something. Why are they wound around a soft iron core? They act to increase. And concentrate the magnetic flux within the core. They act to increase and concentrate the magnetic flux within the core. What does that mean? Now, one of the functions of this soft iron core in the primary and secondary coil is that they help to ensure that the magnetic flux continually changes in the transformer. Don't forget that according to Faraday's law of electromagnetic induction, he said whenever there is a change in the magnetic flux density of a field, whenever there is constant changes, and what brings about the constant changes is the flow of electric current, the flow of current. So when current flows, when there is interactive forces between the electric field and the magnetic field, current flows, and when current flows into this field, there is constant changes in the magnetic flux. So according to Faraday's law of electromagnetic induction, it states that, according to Faraday's first law of electromagnetic induction, it says whenever there is a change, there are changes in the magnetic flux density of a field by virtue of the interactions between the electric field and the magnetic field, and EMF is induced. So that is what the function of this soft iron core. The same way it functions in the transformer is the same way it functions in the generator. So it helps to bring about constant change, concentrations in the magnetic flux of the field. And whenever there are changes like this, an EMF is induced. And it says the strength of the EMF is directly proportional to the field. The strength, how strong the EMF is will determine how strong the field OB, you understand? So that is the function of the soft iron core, to increase and concentrate the magnetic flux within the core. Now it is also laminated. Why is it laminated? We can say it is laminated, or it is insulated. Why? Like we said earlier on, that as long as there are conversions of energy, electrical to mechanical, mechanical to energy, to electrical. Don't forget the law of conservation of energy. Energy can neither be created nor destroyed. But can be transformed from one form to another. So in the process of transforming energy from one point to another, from one form to another rather, there are energy losses. And one of the way energy is lost in the transformer is eddy currents, through the eddy current process. The eddy current process. So one of the reasons why these soft iron cores in the primary and secondary coils the transformer are laminated is to reduce. We cannot stop the energy losses. It will happen definitely. As long as there's energy transformation, it is bound to happen. So it is bound to happen. But one of the ways to reduce these energy losses is by laminating with iron sheets, by laminating the soft iron core, or by insulating it. By laminating it or by insulating it. Okay, quickly we see the diagram of a step-up transformer and a step-down transformer. I will talk more about it when I will start solving examples involving transformers. Okay, so you see the step-up transformer and the step-down transformer. What major difference can you see? You see that for a step-up transformer. Don't forget now, what are we stepping up? Which voltage are we stepping up? Are we stepping up the voltage in the primary coil, or the voltage generated in the secondary coil? The answer is very simple. We are either stepping up or stepping down the voltage in the secondary coil. The voltage in the primary coil is constant. It's like it is received from the main power source, from our electrical generating stations and all that. But the one in the secondary that goes to your house, that is the one we need to step up or step down. So if the voltage is very high, we'll step it down by using a step down transformer. And you can see that in a step down transformer, the number of turns in the secondary coil has reduced. It's now less than the number of turns in the primary coil. Why? Because we have stepped down the high voltage. The primary coil still maintains its high voltage, but the secondary coil that is being distributed to your houses, the voltage has been stepped down. If you look at the step down transformer, we have just 4 turns. 4 turns. Number of turns in the secondary coil is 4, while that in the primary coil is about 1, 2, 3, 4, 5, 6, 7, 8, 9 or thereabout. But if you look at the step up transformer, the voltage from the main source is low. That means the number of turns in the primary coil will be less than the number of turns in the secondary coil. Why? Because we want to step up the voltage in the secondary coil. We want to step up the voltage in the secondary coil. So in a step-up transformer, the voltage in the secondary coil is higher than the voltage in the primary coil. And also the number of turns in the secondary coil is higher than the number of turns in the primary coil, because you are stepping up the low voltage supplied from the primary source. Then why? For a step-down transformer, we are reducing the voltage supplied by the secondary coil, while that of the primary coil remains high. Now, quickly before we go into calculations, let's see mutual inductance and the principle of operation of a transformer.